Going to be the lecture video to go along with our lesson on either August 24th or 25th. The idea is that you are watching this before you come to class so that you are better prepared for the problems I'm going to be doing on the board in class and the notes that I'll be giving you in class. This is the very first one, so if you're watching this after class, that's fine. But try and get on top of that so that you're always watching these before class. All right. You should have your notes out. I always want you to have your notes out while you're watching these lecture videos. I can check those in class to make sure that you're doing them. Don't just sit there and watch this. Be taking notes. It does help you remember this. All right. At the top of those notes, you should put today's date. Just go ahead and do whatever day you're watching this. It doesn't have to be, super precise. It's just to kind of help you stay organized. And if you know what day I gave a certain lecture, you can go back pretty quickly and find that day. Okay, so I'm going to put a question in here and pause the video for you to type everything you remember about PEMDAS. Hopefully you remember something. If that's a totally new word to you, then you can just make up what it stands for. That's okay, but I want to see if some of you remember what PEMDAS is, what it stands for, and tell me everything else you remember about it. Okay, so hopefully you wrote me a few things about PEMDAS, but we're going to go over it again today to make sure that we've got all the details right. So our goal is to start reviewing PEMDAS. Well, why are we doing this? So PEMDAS is the order of operations in math. And so why do we need to know that? Well, just like how you need to know to read left to right in a book, PEMDAS tells you how to read the math. And you don't always read math left to right. Sometimes you read it or you compute it inside out, or you jump all over the place. All right. So in your notes, you should write that word PEMDAS. And now let's write down what each of those letters stands for, starting with the P. P stands for parentheses. So the first thing we're going to do when we approach an algebraic expression is we're going to look for the parentheses, and we're going to see if we can simplify what's inside. All right, if what is inside the parentheses is totally simplified, we can't combine the numbers in any way, or if it's just a single number, then we can get rid of the parentheses. We just drop them. Now, not all parentheses look the same. Normally, they are these curved brackets. Sometimes they can be square brackets. But another thing that counts as parentheses is a fraction line. All right, so this counts because it's grouping together whatever's on top and whatever's on the bottom, especially if it's a very long fraction line. It counts as parentheses. All right. E stands for exponents. All right, so if we see an exponent, we want to replace that with a single number wherever that happens. All right. M stands for multiply. And D stands for divide. And I'm going to write these in the same color because multiplying and dividing are really just two sides of the same coin. And these need to be done together left to right. All right. And then the last two, let's pick a different color for those. A and S, that stands for add and subtract. And just like multiply and divide, these two are also done together left to right. All right, so make sure your notes look like this. It's time for us to start practicing with this. So here we have an algebraic expression, -4 minus a -6. But it's written with a couple extra symbols. So we need to simplify this down as much as we can. In this case, we're going to be able to simplify it to a single number. In order to do that, we've got to apply PEMDAS. So the first thing in PEMDAS is parentheses, and I do have some parentheses here. How do I get rid of these? Well, I would simplify whatever's inside, but whatever's inside is just a single number, so these can be dropped. So this can become just -4 minus a -6. All right, it's fully simplified, so we're going to drop the parentheses. And let's write what we're doing in our notes here. All of these example problems should go into your notes too. So drop the parentheses because the inside can't be simplified. All right, now here's another trick. Whenever I see minus a negative, I'm going to replace that with a positive. So minus a negative can become a positive. So I've got -4 minus a -6. This becomes -4 plus 6. All right, and now that I've dropped these parentheses and done this trick with the minus the negatives, now I can do one of the very last things in PEMDAS, which is to do the addition. The 4 plus the 6, they come together to become a +2. All right, and I can prove that on a number line by drawing out the numbers from -4 to 2. I started at -4, all right, but then I added 6, so I'm going to move 6 to the right, 1, 2, 3, 4, 5, 6, and you can see I land at a +2. All right, so that's a way to visualize what it means to add 6. Okay, here we've got another one, 8 plus 2 times 3. Have we seen this before? So you might have learned to use an x for multiplication, but we're going to start moving away from that because now we want to use x as a variable, and so we're going to use a dot for multiplication. So a dot means multiply. All right, so I've got two operations here, an addition and a multiplication. Which one goes first? Well, not the addition, even though it's the one the furthest to the left. We're going to go out of order here. We're going to do the multiplication first. 2 times 3. 2 times 3 comes together and becomes a 6. Now I've got 8 plus 6. Add these together and we get a 14. Now you might say, well, does it really matter? Like we multiplied it then added. What if we added then multiplied? Maybe we just get the same answer and this doesn't matter. So let's say we go out of order. We do the 8 plus 2 first. We get 10. We keep the times 3. Then we do this. Now we've got 30. So we did get different answers. So order does matter. We can't do this. All right. Here's another one. So here's how I would say this. I would say the quantity, that lets me know that I've got some parentheses here. So the quantity of 9 plus 4 times the quantity of 3 minus 2. So here we've got parentheses, and we can simplify what's inside of them. The 9 plus 4, that does simplify to become a 13. So even though addition would be one of the very last things we do in PEMDAS, we move it up because we have to simplify the parentheses, which is the very first thing. So parentheses are really useful because they can help us tell the computer or whoever's doing the calculation what order we want things done in. All right, again, we got parentheses over here, the 3 minus 2, that's going to become a 1. The 1 can't be simplified any further, the 13 can't be simplified any further, so their parentheses go away. Now I've just got 13 times 1. Anything times itself is just, or anything times 1 is just itself, so our answer here is 13. All right, so I'm going to put a couple more questions for you to do here. Try them out. This is just a completion grade. I want to see how well you guys are doing now that you have hopefully relearned how to simplify using PEMDAS.